Hello, everybody. What I want to do here is go over chapter 6 a little bit in some more depth with you. Um, so, what we're doing in chapter 6 is we're taking arguments in ordinary language, we're breaking them down into symbolic language or logical language, and then we're placing them on what are called truth tables. So truth tables allow us to figure out whether or not an argument's valid. So that's what we use them for. So what I want to do is I want to take a regular argument and I want to symbolize it for you, and I want to work through a truth table with you so you'll be able to understand it a little better. Okay, so the first thing we're going to do is we're just going to start with an ordinary argument. And in ordinary language. This isn't a very good argument, but it's one that I think helps us clarify what we need to know. Okay, so here's the argument. So either Argentina or Brazil will win the World Cup, let's say. Argentina will not win, therefore Brazil will win. Okay, so the first thing I'm going to do is I'm going to translate that into logical language. Okay, here's what we have. So I use A to symbolize Argentina winning. I use B to symbolize Brazil winning. And what I do there is I use the logical operator, which is our wedge, which helps us symbolize or. And then you can see in the second premise I use a tilde, which is for negation. So it just reads either A or B, right? Not A, therefore B. Okay, so there's my symbolized argument. Now what I want to do is I want to put it on a truth table, because the truth table is going to show me whether or not this argument's valid. Okay, so here's what I do. So let me get that there. So as you can see, I write it out horizontally here, and I separate it with those slashes in order to show that this is the first premise, that's the second premise, and the two slashes show us the conclusion. Right? So I write it out horizontally like that. And now what I want to do is I want to use my book here. It's pretty handy. In the back of our books, it shows us, actually it's in the front here, on the very first pages, it shows us the rules for truth tables. If you look at truth tables for the propositional operators. So what that means is it shows us how certain statements relate to each other using the rule of the logical operator. So that's getting a little confusing, but let me first just lay out the logical possibilities here, and then I'll show you how to use the rule. So this is what I would do here. Okay, here's what I've done. So these are what I call logical possibilities. So what that means is, if you look at our first premise, it means that A could be true and B could be true. That's one possibility. Another possibility is A could be true and B could be false. Another possibility is that A could be false and B could be true. And the final possibility is that they both could be false. Okay, so that also gives me the logical possibilities that I can just plug in to my other premises. So you see there the second premise, not A. I just copy over the same possibilities here. So the TTFF, because those are the possibilities for A. But then I reverse them because we have a tilde, so it's negation. Now with our conclusion B, I just copy over the possibilities um, just the same as I did for the second premise. Okay, so now we actually have to use one of our rules here in order to determine the truth value of the whole statement. So the first premise, A or B, has a truth value for that whole statement. And the way we get it is we compare the two logical possibilities. So take the first line, true and true, and then we apply the rule for the logical operator. And we find that again in our book. So we find if both sides are true, then that means the statement as a whole is true. So I write that in the middle here. Like so. And then I go down. I just compare the second possibility and the third and the fourth. So if one side's true and the other side's false, and I apply the rule, I get true. And so I do this all the way down here. And then I circle it, and that's going to help us later. So here's what this looks like. So now we have the truth value of the entire statement for each possibility. So we have true, 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 false. Now that's also how the rule works for the wedge or our or statement. There's only one case where it's false, right? That's when both sides are false. So we can commit that to memory. It helps us along the way. So now what I want to do, now that I have the truth values of the whole statement for our first premise, and I have the truth values for the second premise as well, which we don't need to apply any rules to, and I have the truth values for the conclusion, I want to go horizontally and compare them all. So let me show you. So I circle all of them so I know what I'm doing, right? And I compare them horizontally. So the first line we have true, false, true. Okay, I'm going to put a little check mark there and I'll tell you why in a second. I put a check mark next to that because it shows that there's nothing wrong with that line. So the argument is still valid as far as we're concerned because there's only one case that can prove the invalidity of the argument. So both the premises would have to be true and the conclusion would have to be false. That's the one case that shows the argument's invalid. Any other case just shows the argument's fine, it's valid. So we look at the second line. We go down in the same way. True, false, false. That's fine. So I put my check mark there. We look at the third line horizontally there, T. So we have true, true, true. That's fine. I look at the last horizontal line there. We have false, true, false. So that's also fine. It hasn't violated the one rule that would show that the argument's invalid. So we have a valid argument. Does that make sense? So the argument would be invalid if we had one line horizontally that said true, true, false, right? that's the one case that shows the argument's invalid. So this is how we do truth tables. We put the argument symbolized horizontally on the top. Then we list our logical possibilities like that, and then we apply the rules where we need to when we see those logical operators, and then we compare horizontally and look for one line that shows true, true, false, for instance. And and that's really all there is to it. I want to do another example where maybe it gets a little more complex, so we can try to get better here. Give me 1 second. Okay, this one is definitely more complex. So we see the first premise is if A, then B. The second premise, if A, then B, then C. And the conclusion is C and B. So now one difference you see here is since we have 3 letters, right, we have A, B, and C, we have more logical possibilities. And so there's a way to just memorize what those are anytime you have 3 letters. So let me list them out for you, and then you can commit them to memory. Okay, so here they are. And what you'll notice is now we have 8 lines rather than 4 when we look at these possibilities. And there's always a pattern when we have 3 letters, right? And so the first letter is always T, 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 F, 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 all the way down. The second, you see there's T, T, F, F, T, T, F, F. And then the third, we have true, false, true, false, true, false, true, false, all the way down. And so that always works when you have 3 letters or 3 symbols. So now what I'm going to do, the next step here, is to just plug in the possibilities here. You can see in the second premise we still need to list the logical possibilities for A and B, and then in the conclusion we need to list them for C and B. So I'm just going to plug them in. I already have them. So okay, so there, I have them all listed out. So now I'm just comparing them based on the rules for the logical operators. So I'll take the first premise, and there are rules that tell me what to do when one side's true and the other side's true under the rule of our horseshoe here, or our if-then symbol. So let me just fill it in based on the rules here. Okay, I've done that. And the rule for our horseshoe statement, our if-then statement, is that when one side's true, or I should say the first side, right? So underneath the A, when that side's true and the second side is false, then it's false. Every other case, it's true. So you can see in the third line down there, that's the only time it's false, right? But then there on the fourth line, it occurs again, and we have false. And every other case is true. So again, you can find that on the very first page of your book in the insert there. It tells you those rules. Okay. Now I do the same thing with the second premise. So I'm using, again, the if-then rules here to show the truth values. Okay, so now I have the second premise here. See, I'm circling those truth values because I want to be able to keep it straight, which truth values I compare when I go horizontally in the last part of the table. So there they are. There's something tricky in the second premise here, and it's since we have two logical operators there in the premise, we have to find the main one. And that's the value we really want to compare in the end when we compare the values horizontally. So if I just look at what that statement is, it says if they, or if A, then B, then C. What it's really saying is if this A, then these other things. And so we can see that that first horseshoe is our main logical operator. That's the one we want to use when we compare these in the end. So I'm just going to remind myself by crossing out the second one here. So I just drew a line through it so it won't confuse me later. Okay, now I'm going to get the truth values for a conclusion here, which is an and statement, and there are rules for and statements, and I'll show you them in a minute. Okay, here they are. There are the truth values in the conclusion, and so there's only one case where it's true, and it's when both sides are true. You can see it already there in the first line. In every other case, it's false. So you see on the second line we have a false and true, we get a false. Right? So that's the rule to commit to memory, and you can see there midway down we have another case where both sides are true, and so the value is true. Okay, now what I want to do, again, is compare them horizontally, compare the values we just generated, and I'm looking for that one case to prove invalidity. And it's when we have a true underneath the premises and a false in the conclusion. So let's go ahead and go through this, and I'll put check marks each time. First line, we have 3 trues, and so that's fine. I give it a check mark. Okay. Oh, the second line. I already have true beneath each premise and false beneath the conclusion, so I don't even need to finish going down each line of this truth table, I can already see that the argument's invalid. There's one case where the premises are true and the conclusion's false. That proves the whole argument invalid. So I would just write invalid next to the argument, like so. Okay, so that's, in a nutshell, that's truth trees, and I hope I didn't confuse you more. I hope it was helpful, but if you want to ask me questions about it, feel free. And like I say, I'm always available to Skype with you if you would like to Skype. And email is fine too. And I welcome your questions, and so far the class has been great. Have a good day.